Hi, Bianca here. I'm in section 12D of Math 32 for the fall 2020 semester at UC Merced, and I'm going to be talking to you about histograms. So what is on the agenda for today? We're going to be looking at the different characteristics of a histogram. We're going to be looking at a hands-on example of a histogram as well. We're also going to be going over why histograms are useful, as well as the closing statements and thank yous for a great semester. So what is a histogram? Essentially, it's not a bar graph. Histograms as related to statistics is a way to represent a frequency in the frequency of a typical range. Carl Pearson is credited for the introduction of the histogram, and I've actually linked the abstract that I read of that I believe to be the paper being about histograms back in I believe it was dated to 1859. I have the link at the end of the presentation, and I can include it in the description below. In my last video, I went over Benford's law, a natural phenomena that occurs in the collection of random numbers. And at first glance, at least in my head, remembering the project, I thought that the graph presented by Reddit user rdataRNJV was a histogram, but it was actually a double bar graph. So then this raises the question, what is the difference between a bar graph and a histogram? Well, a bar graph, while similar in aesthetic, can represent the quantity of data collected for any given category. A histogram, in contrast, is restricted to a continuous or discrete variable, being that they need to be numeric values. We also see that the histogram can also represent ranges instead of just single numeric values or single quantities. And these values are going to be represented by bins rather than bars compared to the other graph. The bins for each graph can vary depending on width and number of bins as well. And each bar graph has a fixed size for each category. So what is a histogram mathematically speaking? Well, it's a function that counts and categorizes the number of occurrences n over a specific range. This range is known as bins, or k. The equation for this function is going to be n equals the summation over the period of k, with the initial value I, m, to the I. I really hope I said that right. And to define your number of bins, it could either be given or you could calculate it. To calculate it, there is many different ways. I believe there are about 10 different ways you can take a look at defining your k value, but a general way to do it would be subtracting the max number versus the lowest number in your data set over the height of your suggested bin, and then treating each range with the ceiling function. Those braces are going to indicate the ceiling function, and if you need a little refresher, the ceiling function is going to be that graph we learned about where you have an open circle and a closed circle, but in histograms, at least typically, you see that the smallest value is not included, but the highest value is. So here we're going to have a hands-on example. I took my Engineering 155 final project, and I counted the frequency that each number appeared, similar to how Benford's law is applied like I did in my last video, but this time I'm not too picky about where the number comes from or if it's its own individual number or the beginning of the number. As long as it appears on the spreadsheet, I wanted to count it, so I just used Control F and went through each individual page and added each amount up to get these values. So numbers 1 through 9, the frequency in their appearance goes from 5,000 all the way down to 3,000. We don't really see a clear Benford's law curve. This could be because I wasn't very picky about where I got my numbers from or how many times they appeared. But we do see that there is a much higher number of 1s than there are of 9s. And there is a very, very, very slight curve happening there. It was a very good opportunity for me to see the density and number distribution of my numbers. And if for some reason we had altered the numbers in a false way, we would have seen a lot less of a resemblance to Benford's law. I would also like to note that the x-axis here for my histogram actually does not include 0, nor does it go farther than it needs to as far as range. This is because histograms are very useful in only showing the data that you really want to see. You don't really need to include anything that's unnecessary. So here we come to why histograms are important. Histograms summarize distinct or continuous variables, making it perfect for comparing large data sets. When representing data over a histogram, adjusting the bins over the same data set can allow you to take notes of different trends in distribution. And using histograms also allow you to gain a general sense of distribution density curve. And while I couldn't necessarily find commercial ways of using histograms, I do remember Lab 8 and felt that the Lab 8 that we did in Math 32 was very beneficial to our understanding of the benefits of histograms, because when looking at the graduation rate over the nation or the colleges included in the data set given for that lab, we can see that we're comparing the graduation rates over many, many schools, but we don't necessarily need to take note of each individual school. We mostly want to see the occurrence that is happening across in a specific category. And this is one of the reasons why I think histograms are so useful. It's a very simple way to look at data, and you can also see the distribution. If we happen to see that graduation rates were very, very low for the majority of all of the data, we would be able to question if something needed to change, or if everything was really high, we can look at what the higher schools are doing compared to the lower schools, and then see if there's a way to balance out that curve so we don't have any kind of skew. All right, so that's going to be all of my presentation. Thank you for watching, and remember, histograms are not bar graphs. The number of bins can be calculated or selected, and the width of each bin depends on how you want to present it. There are so many different tools for creating histograms. We used RStudio during class. I happened to use a different tool to create my histogram just because I wasn't doing ranges. But yeah, I really hope you enjoyed my presentation, and thank you for such a great semester.